There are N houses in a village. We want to supply water for all the houses by building wells and laying pipes. For each house, we can either build a well inside it directly with a specific cost or pipe in water from another well to it, which has a different cost. Find the minimum total cost to supply water to all houses.
Mm.
Hi everyone, we're here today for another Exponent mock interview with Daisy. For those of you who aren't already familiar with Exponent, Exponent helps you get your dream tech career with our online courses, expert coaching, peer-to-peer mock interviewing platform, and interview question database. Check it out at tryexponent.com. Okay, it's so great to have you with us today, Daisy. Would you quickly introduce yourself to our viewers?
Hi, my name is Daisy. I'm a software engineer at Twitter. I've worked on various different domains. I started my career at Adobe, where I was building macOS applications. Then I moved on to Google, where I was working as a backend developer for an API management platform. Currently, I'm part of the ads team at Twitter, and I'm working on a tool to evaluate the importance of the features used in our machine learning models in production.
Sounds like you've worked on a variety of really cool things. It's great to have you here. Okay, so let's get into our question for today. The question is, there are N houses in a village. We want to supply water for all the houses by building wells and laying pipes. For each house, we can either build a well inside it directly with a specific cost or pipe in water from another well to it, which has a different cost. Find the minimum total cost to supply water to all houses.
So I have a few questions. So is it possible to like build a well at each house, or and if not, if it's not possible, then what is the input in the well array?
Yeah, it is possible to build a well at each house, though it may not be the most cost-efficient method. Yeah, sorry, what was the second part of the question?
No, the second part was was in case we're not able to build a house at well at each house, then what would be the corresponding cost for that?
Gotcha.
But okay.
Okay.
So can I assume that all these costs are positive?
Yes, you can.
And can I also assume that we are able to build a pipe at every pair of houses?
Mm-hmm.
Okay, uh, fine. So I'll go. Uh, okay. So I understand that for each house, pump to supply water to that house, we either build a well at that house, or we pump in water from another house through a pipe.
Yeah.
And okay, so this means that like I build a well at one house and I can use the water supply at that house to pump water to other houses, like if it is cheaper to pump water as compared to building a well.
Yes,
Uh,
exactly.
and we might also end up with like multiple different groups of houses, where a group means like there is uh, one house which has a well and the other houses are connected to that house
Yeah, makes
by
sense.
pipes.
Mm-hmm.
And I can see that this problem, like we can model it as a graph, like in the example that is given here. So our nodes can be the wells. So
Okay.
like we have three nodes, n is three, so we can have like three nodes. Uh, let's call them node one, two, three,
Mm-hmm.
and these nodes represent the houses.
Mm-hmm.
And we can have edges between these nodes, like for edges would be representing the pipes that we have, like between uh, one and okay, I'm sorry, I think for this example the naming starts from like node 0, so I'll name the houses at 0, 1, 2, and we can have and we can represent the pipes as edges, like we can have uh, like in this example we have edge from 1 to 2, and the weight of this edge would be 1, like the cost of building this pipe. And then we can have another edge 0 to 1 with the weight 1, another edge 0 to 2 with weight 1.
Mm-hmm.
And to represent the wells, I think the wells can be represented as self edges, like edge from the node to itself. And the cost again would be like the cost of building this well.
Mm-hmm.
But then we would end up with like multiple multiple graphs. And to represent it as one single graph, I think what we can do is that we can come up with a dummy node, and we can call this node, let's say this dummy node is node -1 or I don't know, a node X. And from this node X, we build edges to all the other nodes, the nodes that represent the houses. So we can have a node from X to 0, X to 1, X to 2, and the weight of these edges would be the cost to build a well.
Okay.
So we have
And
1, 1, 2.
right. So you're saying that this basically keeps the entire graph as a single connected component.
Yeah.
Yeah. Okay.
Yeah. So now I see that this problem, like we can reduce this problem to uh, like the problem reduces to finding a single uh, a set of edges in this graph wherein uh, the cost of these the total cost of the edges is minimum and it connects the entire graph.
Yes.
Uh,
That sounds right.
so yeah, which basically is like what we call a minimum spanning tree.
Right. Yeah.
So yeah, so I'll quickly go ahead and like I'll write the code for this problem here. Let me comment out this part here.
And okay, so your plan is to first like find the minimum spanning tree and then like add up all the costs in that minimum spanning tree to get your solution.
Yeah.
Okay. And what like algorithm are you planning on using to get the minimum spanning tree?
I'll use the Kruskal's minimum spanning tree algorithm. So like which means like I'll sort all the edges by the cost, and then I'll pick the minimum weight edge at one by one, and then add them up. If so so what Kruskal's algorithm does is we have two sets of nodes wherein one node is the set that belongs to a minimum spanning tree and another node is the set that does not belong to the minimum spanning tree, and we sort the edges by their weights, and each time we pick the minimum weight edge and we see if like using that edge we are able to add more edges to this set which has the edges in the minimum spanning tree.
Where we're not reusing a node, right?
Yeah, which means we
Yeah.
are not reusing a node.
Okay. Yeah, that sounds like a good plan to me.
I'm thinking like for simplicity, like I'll have the dummy node as the node 0 and then other nodes they start with like 1, 2, 3.
Sure. Okay, that makes sense. Sorry, just to clarify, the union find here, that's just for like connecting all of the.
Yes.
Okay.
To yeah, so initially like we have two disjoint sets wherein one set is empty and the other set has all the nodes, and each time we pick an edge we see if like either of the two edge is part of this set which has like all the edges with the minimum cost. uh,
Yep.
if it's already there then we don't pick the edge, and if it's not there then we pick that edge.
Okay, I see.
Mm.
Okay, so this find function it's just checking that the node X is in the same like component.
So how union find works is that initially, like all the nodes in the graph, I assume that they are a single, they are individual graphs, which means like the parent node is the same as themselves, and as and when we start grouping them together, so I would have
Right.
one node as other nodes, one node as a parent and the other node as a child of that. So the find function does like returns the parent of that node.
Right. Okay. So make sure that everything in the same connected component returns the same
Yeah.
number, basically. Yeah.
No, there are like some optimizations to this as well, but
Mhm.
I'll get into those later, and I'll just do a basic implementation wherein I can just do
Yeah. Sure.
parent
That
of.
sounds good.
Okay. So now let me create. I also do an n minus minus because the total number of edges in our minimum spanning tree would be n. So
Okay.
as soon as like we're done with n edges, we can do like an early termination for that.
Okay.
So if n is equal to 0. Yeah, so I think that would be. Do you want me to like write a test case and then test it out?
Yeah. It'd be great to see you test your code.
Okay, great. Okay, let me also write the header functions. And I need to include algorithm because I'm using the sort method.
Okay.
Boolean. I think it's called. Okay, it's called a bool in C++. So.
Yeah. Okay. What is the expected answer here?
So we have 3 wells, and I think the expected answer here should be 3, because like we can build wells at 2 houses and then a pipe to pump water from that house to the third house.
Yeah.
So the answer here should be 3. Give me a minute. Let me think why that is not the case here. Okay, I think one issue is that I totally forgot about the dummy node that we have. So it should be like I is equal to 1, 2, n, and then I minus 1. So this incorporates for an extra node.
Yeah.
Okay, I think in our input, like we are starting at 1, 2, and then like we should actually be starting at 1, 3, like what I discussed. Like that, I think like 0 here is getting confused for the dummy node that we have here. So yeah, so now we have the correct.
Okay. Yeah, can you test a few other test cases?
Yeah, sure. Like, what do you want me to come up with those test cases?
Yes. Like, what do you think would be valuable to test?
Okay, so let's assume, okay, so like a test case wherein like all these numbers are a bit different, like a few more values. So, so let's have it like Wells cost is 1, 2, 3, and 4, 5, 6. So in this case, like the minimum cost would be like if we like just build a well at all of these houses, which is 6. Or maybe a case wherein it's cheaper to build a pipe at every house, but then we still need a well. So the minimum cost would be like 6 plus 1 plus 1 rather than 1 plus 1 plus 1. Or do you want me to like test some other cases as well?
Yeah, so far you've only had cases where n equals 3. I think it'd be worthwhile to try other values of that.
Yeah, sure. Three, 4, 5, and then
so right, so you want to build a well at index 3 for sure, right? So the cost of 2. And then for
yeah,
at
so
index.
And then yeah, so it's a well at index 3, which is cost of 2.
Yeah.
And from index 3 we can I'm not sure if we want to pump in water to index 4 because that would be cost of 8.
Yeah, so
but then we can have like a well at index either one of 0, 1, and 2 with the cost of 6, and then we can pump in water to other 2, and then the cost of okay.
yeah, so that's actually so wells at index 3 and 4, right?
Yeah.
Yeah. Yeah, okay, that makes more sense to me. Yeah, and then the other
other test cases.
okay, yeah. Makes sense.
Do you want me to come up with other test cases as well?
Okay, is there like there's one more edge case I was thinking of that like maybe you haven't tested yet?
like a case wherein like we don't have any houses, but then that would not make any.
Yeah, so what if you just have like an empty input, like if n equals 0? Hello? Sorry, I think your microphone suddenly stopped working. I can't hear you anymore.
Um,
Oh, okay, I
can
can
you
hear
hear
you
me now?
now. Yeah. Mhm.
Okay, okay. An edge case, like a case wherein the cost to build a build a well at somewhere is 0.
Uh, so n equals 0, basically.
Yes, n equals 0.
Hmm.
Okay, so in that case, uh, both of these would be empty.
Yeah.
Okay, and then so this will just return 0.
Great. Okay, that looks right to me. All right, so great job. You did a really fantastic job, I think, of like modeling this problem as a graph problem. And I'd love to hear what you thought of this interview. Like, what do you think went well, and what do you think you'd want to improve on?
I think like my explanation of the problem, like if I'm not sure, like if I was able to explain it very clearly, because like graph is a visualization problem, so it's like easier to explain, easier to visualize, like when you can just draw it out.
Hmm.
Uh, yeah, and I think like for my union find code, there are possible optimizations for it. Like we can use union by rank and path compression that uh, optimizes it better.
Okay,
Uh,
how does that optimization work?
so what union by rank does is that suppose you want to group two uh, nodes together, which
Mhm.
are like part of different graphs, and in what union by rank does is that uh, we always add the smaller subgraph as a child of the larger subgraph.
Hmm.
So in that case, it takes care of cases wherein we have a very skewed graph, and then to it and it does not take a lot of time to iterate to the root of that.
Right. Yeah. Okay, makes sense. Um, okay, and then so amortize, is that still like the same runtime?
Yeah, amortize it's still the same runtime.
Right. Yeah, and it just might change the constants, right? Yeah.
Yeah.
Okay. Great. So I'd love to hear a little bit about like what the runtime and space complexity of this solution is.
So for the runtime, like we are sorting the edges, so it's figure of e log e, and there is the union find algorithm. So we have e log b for that.
Hmm.
Now e would actually be like e can actually be a maximum of like v square. So which means that this can either be like e log e or e log v. It's the same thing.
Yeah, so that means that e log v is could be like e log e squared, which is the same thing as what?
Yeah.
And then you can move the exponent to the front, right?
Yeah.
So then that would be like 2 e
E
log
log.
e,
Yeah.
which then, so it's O e log of e, right?
Yeah.
Yeah. Yeah. Okay. Awesome. What about the space?
Uh, the space complexity would be e plus v,
Okay. Yeah. Because you're storing,
the edges and
yeah, you're
the
storing all the edges and the
yeah
vertices. Yeah. Okay.
nodes.
Perfect. Yeah. Okay. So I agree with a lot of those points, but I thought that there was a lot that you did really well too. Like I like that in the beginning you asked a lot of detailed questions to verify your assumptions, like whether or not the costs are always non-negative, for example, because that could completely change the problem if the answer to that question were different. And I really like that you explained how the input could be represented as a graph because that's important. You can't just say it's a graph. You have to say like, okay, like what the nodes are, what the edges are, and why are we using a graph. I think the part of that explanation that could have been more clear is that I had to prompt you to ask, like, okay, like, what are you using the minimum spanning tree for? Like, what's the purpose? And like, what kind of algorithm are you using to actually find the minimum spanning tree? And then I didn't find out until later on that your algorithm for finding this minimum spanning tree also actually includes a union find, right? Um, yeah, okay, great. But I also thought it was really clever that you managed to use a solution of the dummy node to basically connect the entire graph, which is a common strategy in a lot of graph algorithms. And I thought that coding-wise, I really like that you used object-oriented programming to, to structure your code. So you had this separate like edge struct, which made the code a little bit more clear. So I think the code could have actually been even a little bit more clearer though, because for example, you have like some of your variable naming like pipes. So pipes is actually like a vector of vectors, right? That actually stores the costs of the pipes. Whereas I was a little bit confused as to like, you could read that as like, oh, pipes actually just contains like the indexes of the pipes or something. So maybe you could like rename it to like pipe costs and so on. Lastly, I think it's also good to like explain your code as you're going and also explain like the like efficiency too without necessarily being prompted. So what did you think of all of that?
Yeah, I think those are very helpful tips, and I'll definitely like keep those in mind, like for my next coding interview.
Mhm.
And yeah, thanks a lot.
Yeah, awesome. Thanks for being here with us today. Thanks for everyone for watching and good luck on your upcoming interviews. Bye, everyone.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video was valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching and good luck on your upcoming interview.